Good afternoon, everyone. So I'm here to talk a little bit about delivery of geothermal projects. My name's Rick Evans. I'm the Commercial Director at GT Energy. We're a developer of geothermal projects. We're currently working on 4 across the UK. I'll talk a little bit more about those as we go through. I'm here to talk a little bit about our experiences from those and extrapolating that out to how we can help customers across the UK to deliver their geothermal dreams. I'm looking across the room. I'm seeing some faces that were here earlier on to listen to the BGS, but we sort of fit after that. So you heard from them a little about the prospectivity of different locations, some hotspots, some not spots, and what we're talking about here is taking what we hope they've given you as an idea that they've got a potential, and how do we then bring that potential to reality and ultimately end up with that fantastic day when the likes of Dr. Kieran Mullen come along with their great big shears and cut through the red ribbon in front of your new energy centre. Delivering a geothermal project is not straightforward. I want to start and finish with that. There are hurdles along the way. There are inherent uncertainties with realising a resource, a heat resource, that's potentially 3, 4, even 5 kilometres underneath your feet. I've captured here a number of those on the page. Fundamentally, how do you know it's there? Once you know it's there, how do you know how you're going to get through the planning process? What regulations, what permits do you need in order to extract that? We're not talking about greenfield development here. We're talking about existing infrastructure that's potentially been there for 10, 20, maybe even 100 years. So how do we bolt onto that? How do we assist in its decarbonisation, not just potentially for the trust, but actually for the wider community, the stakeholders around that? We've just heard about the potential opportunities for heat networks. Geothermal bolted to a heat network is a fantastic opportunity. So how do we bring that to life? Looking at that, then there's the commercial realities of life. This has got to work for everybody. It's no good extracting the resource that's down there, and doing it at a cost that no one can afford. So we need to match the supply of heat to the demand and at a price point that's realisable and viable for everybody. Of course, there's lots of money out there, both from within the private sector and also the government sector in the form of grants. PSDS, I heard from Clive, has just gone down, but there's money available from there. There's the Green Heat Network Fund, which is also providing money for geothermal projects, but those generally come with constraints. They come with time-bounded limits in terms of the way to spend them. So you need to be able to navigate that system and work out what the best way to deliver the project. What I'm about to present to you is a workflow. Now, this isn't a unique workflow to GT Energy. If you were to put this in front of Eden, or in fact the BGS showed something very similar to this today, this is an industry standard. We'll all use different names like assessment and feasibility and design. That's immaterial, and I'm looking here at Tony, my colleague, who always laughs at me when I start getting into the buzzwords, as he calls it. Frankly, the workflow is immaterial. What's important are the fact that it's a series of steps, and the steps are designed to de-risk the project, to reduce the uncertainties, reduce the cost exposure, not just to the trust, but actually to the developer carrying that out, making sure that you're working through in a step-by-step manner, de-risking it, identifying the uncertainties and closing those in a stepwise manner. So we'll go through those, talk about in each individual step, the purpose of that step, and what it's going to give you at the end of that process. So the first step, some kind of assessment. What this is doing is taking the output from that BGS, what we call a basin level model. It's telling you that you've got hot rock underneath you. It's got potential for a delivery of temperature of hot water at a particular temperature. And what it's doing is identifying what are the questions that we need to answer about its viable extraction. First of all, what temperature is it? Is it worthwhile going after it? Temperature equates to depth. There's one truth in life. The deeper you go, the hotter you go. But as you go down, is it at the right temperature in the right rock type? It's no good trying to extract water or pump water into a rock that doesn't have the porosity and the permeability to get it out. You need to have the right rock at the right depth. All well and good knowing that it's down there, but how do we get to it? You drill a well, okay, but what happens if that drill's crossing lots of faults that we don't want drilling through? So the purpose of the assessment is to look into the ground and understand whether or not we've got a viable project that's worthwhile exploring. At the end of this stage, what we're putting together is a feasibility package, a package that says these are the questions that we've got, and this is how I'm going to answer it. These are the seismic surveys that I need to carry out. These are the slimline boreholes that I'm going to drill down here and here in order to understand what the rocks are. So you're building up a package of works that will then take you on to the next step. The next step being the feasibility assessment. So we've come up with our packaged project and we're going to say, right, is it really there? What kind of surveys, what kind of technologies do I need to employ in order to exploit that? Once I've carried out those surveys, I'm now in a position to come back to the trust and I'll say, well, we can see it's there, but we need to drill to this depth. We need to navigate this particular path. We need to connect up to your existing facility in this way. We need to go through this planning process. We need to go through these regulatory steps in order to do it. Putting all of that together, we come up with a commercial proposition which matches the requirement from the trust, which boils down to this much temperature at this much flow rate, but actually in terms of a physical concept that says this is what my project's going to look like. At that point, we hopefully have a shaking of hands that says, okay, we're ready to move forward and we've got a viable project. Next, we need to engage the bureaucrats, planning and permitting, working with the local authorities, working with the parish councils, working with the Environment Agency, all of which require various sign-offs in order that you can carry out your proposed activities. In order to do that, of course, you need to understand what your engineering designs look like. So you need to go through a FEED process, you need to go through your initial stages of well design, because they in turn have regulatory sign-offs that you need to satisfy. One of the big challenges we've come across as we started working with trusts has been lack of space. Whether or not you've got a hospital in the middle of the countryside or indeed in city centres, there's always a challenge about, can I use this car park? Can we gain access to that field? Will the landowner gives us access over that space? So these again are all the challenges that we need to go through in this permitting stage. And fundamentally, we then come to a point where we're looking at viable designs that have been signed off, they've been approved by the necessary regulators, and we can then progress to the final stage of the engineering path. And that's one of confirming the commercial design. So that's actually then taking our high-level engineering thought process, the FEED, the basis of well design, take it to the next level of detail, in order that we can come up with a fully costed program of works. Why is that important? Well, obviously we then need to be in a position where we can sell you the heat. So it's putting together those costs on one side, together with demand that you and other customers in that stakeholder group around you have identified, potentially even hooking up to a district heating network or working with the likes of Vital in order to connect up multiple customers in the area, and then putting together an overall cost of delivery, which then can be matched to a commercial contract that you can all agree on before you progress into the final stage of the project, which is the delivery. So, delivering a project is just drilling a hole in the ground, right? Okay, we need to go to quite some depth, as we said earlier on. This could be somewhere between 2,000, 2,500 meters, all the way up to potentially 5,000 meters. That in itself is a challenge. You need to have the site, one, maybe even as much as 2 acres, depending on the size of the rig. The size of the rig, in turn, is driven by how deep you want to go. That's going to be tied up and utilised for potentially 12 months, 15 months, all told, maybe once you've considered the construction of the well site. During that time, you're going to mobilise in a rig, and here's a typical sort of rig. That's drilling down to about 3,000 meters there. The height of that is about 50 meters. Land take around about acre and a quarter, I think. Just to one side of this was a primary school. The other side, a public park. So during the construction phase, they actually used this as an exhibit, as a demonstration project for others in the areas to come around and talk about what they were doing. So rather than treating it as a blot on the landscape, it was actually treated as a net advantage to their neighbours. Once you finish the construction of the wells and drill to that great depth, that all gets decommissioned, and you end up with a couple of wellheads. And here's an example here with the ever famous Dr. Kieran Mullen standing next to it, sitting inside a little shed like that, and that's about the size of a few car parking spaces, maybe 8 car parking spaces. So a very small building with all of the gubbins, these wellheads sat underneath it. The space around it can be turned into a park. It can be returned back to a car park. It can be built into the middle of a housing development. All you need periodically is access, in this case through the roof, to be able to come back to the wells and work with them, and carry out a workover, and potentially to replace the pump that's down there. Very simple in terms of the end product, very unobtrusive, and that's all left at the end of the project. It's going to be there 50 years, maybe up to 100 years. The first purpose-built geothermal systems were built in the 1890s, still operating today. The first, let's say, accidental geothermal systems, well, we're all familiar with the city of Bath and many other Roman bath sites across the UK. Running on geothermal, same principle. All we're doing is extracting it from a little bit of a greater depth through manual terms. As I said, we're involved now in a number of projects across the UK. I've listed 4 there that are now working through that workflow that we talked about. We're hoping to start the surveys for Salisbury in the coming month, and Wythenshawe will be earlier on in the new year. Stoke, we're actually ready to break ground. We have carried out the seismic surveys. We've got the planning permission. We've got the EA permits. We're waiting for the grant to be approved, and as soon as that's done, we'll be in a position to break ground and start construction of the well site. And at that, I'll draw breath. If anyone's got any questions, I'd be very happy to answer them. Clive, you have furrowed brow.
Well, I don't know if I can ask it in public, but I mean, this surely Stoke will work if you have to find funds externally to
That's a great question. So why do you need a grant in any of these things? It's not to make the project work, it's to make it more economically viable. In the case of the Stoke project, we have a geothermal well. It's drilling to approximately 3,500 meters, enters the Carboniferous limestone at 3,000. The termination of the well is about 3,500 meters. The geothermal well on its end can be delivered, and we can deliver, you're familiar with our concept of a counterfactual, we can deliver heat from that project below the equivalent price of a ground source heat pump or an air source heat pump. Why is the grant required? The grant's required because there's 16 kilometres of heating network needed to then deliver that heat across the city of Stoke. So we've got anchor loads at the university, at the further education college, at the hospital, at all the council buildings in the centre of Stoke. There's 16.5 kilometres of network winding its way through the streets. So the grant is needed in order to help deliver that and to make the price of heat from us, once it's passed through that network, to be commercially viable for the customers. If you had the customer sat next to the well site, we could do it tomorrow. Hopefully that answered the question. Yeah.
We're certainly not going to let Stoke Hospital struggle, so just shout if they need help.
Unfortunately, Stoke Hospital is right at the other end of the network, which is a challenging part of it. But yes. Anything further? All right. Well, if you have any further questions, I'll be here for the rest of today and tomorrow. So it'd be very nice to hear from you, and we'll take it from there. Thank you.